Okay, here we have a good beef shed, again designed from the late 60s, 70s. These buildings are going to last thousands of years, but they generally tend to be too tight. And what, again, some people forget is that since the 1960s, the productivity of cattle is probably doubled. And what we ask of our cattle, I mean, it used to be in the winter, we'd keep them on a maintenance diet all winter because that's all we could manage. Now they're growing, these animals are producing 2 to 2.5 times more heat and more moisture, critically the moisture. So good shed, generally going to be too tight. The rules are quite simple. If there's 80 cows in here, we need 80 times 0.1 square meters of hole in the roof as a ballpark. And if you ask you for more advice, there's a bit more detail, that will be refined by doing a little bit more mathematics. But anyway, we look here, 80 cattle times 0.1, I need 8 square meters of hole in the roof. And in fact, what I've got here is I've got one of these cranked crown rigid sheets. So in a building 22 meters long, I've maybe got 20, and 20 times 0.067 square meters, because that's what they have, and an outlet you'll find is something like 2 times 0.67, which is about 1.3 square meters. What we need in here for 80 cattle times 0.1 square meters is 80 times 0.1, which is 8 square meters of hole in the roof. And what we've actually got up here is 20 of these crank crown ridge sheets at 0.067 square meters each. So we need about 8 square meters. What we've actually got is about 1.3 square meters. These are completely tight up top. And the thing about that for these cattle is that if there's hole in the roof, because there's so much heat and energy to drive the ventilation system when the wind stops, you will get a huge amount of air with the moisture, and the bugs can go through the hole in the roof if there's enough of it. What we've actually got here is less than 20% of what we need. What's the solution? Well, the solution is more hole in the roof. One of the difficulties sometimes you get with buildings like this, if you have a look up there, is those two top purlins are really quite a distance apart. They'll be at least a meter apart. If this building, you can see again, if it's just over 20 meters long and we need 8 square meters of a gap up the top there, then the gap is going to be approximately 40 centimeters. It's a big old hole, right? Trouble is, the gap, if you took the ridge off, is one meter wide. And actually the engineering, it's a big fiddle to get it sorted. The most expensive way to sort this out is going to cost about 100 to 110 pounds per linear meter. So it's going to cost, let's say, £2,500 to sort it out. You go, well, I'm not going to do that. £2,500 would give us a ridge that we know works all the time. If you had a 3% lift in productivity, I know you'll get a 5%, but let's be conservative. A 3% lift in productivity, and that's the payback, in terms of growth rates or food consumption, FCR. So that's the answer in here. With a solid wall, that's the outlet sorted. We're now onto the inlets. The inlet we have on one side wall over here is spaceboard. So the question is it big enough? Well, we measure it. Okay, so the inside of the building here, 80 cattle. So as a ballpark, 80 times 0.01 square meters is the amount of outlet in the ridge for total. So 80 times 0.1 is 8 square meters. And that is the minimum amount of inlet you're looking for in each sidewall of that same building. So here I am on the sidewall here. I'm looking for 8 square meters of inlet. And this is spaceboard, a board with a space between it, okay? Not Yorkshire board. And generally, tape measure, I've got a 5-inch board and a 1-inch gap. So we're talking approximately 15% of that area is a hole, right? So we then work out, we know the building, if somebody tells me, it's just over 100 centimeters, so that's a meter height, and the building is 1, 2, 3, 4, 5 bays long at 75 feet, 23 meters. So it's 23 meters long, 1 meter height. I have 23 square meters of cladding, and 15% of it is a hole. So I have 3.45 square meters of air inlet on this shed. I need a minimum 8 square meters of inlet in each sidewall. I've done some basic calculations, doing that and doing that. On the other side over here, it's solid to an adjacent building. If for any reason that can't be opened up, then maybe on a site that is not as exposed as this and well ventilated by the wind, you might need to put a fan and a duct, because you can't get fresh air through a solid wall. Here, it's probably not needed because it's extremely well ventilated on 3 sides. The 4th one, it's not a particularly long building, it'll work a treat. It's pretty good. A very common situation, a building that wasn't built as a cattle shed. This was built as a straw shed. In itself, brilliant. But not unsurprisingly, they find they can only put 20 cattle in here. But when you look at the floor area of a building that's just over 20 meters long and 10 meters wide, you feel that you find out that really at 5 to 6 square meter per cow, we should be able to get approximately 40 cattle in here. The reason we cannot get 40 cattle in here is because the ventilation doesn't work, and therefore we get a build-up of moisture that makes the whole place damp and consumes straw. What we need to do is to be able to identify what the problems are, and that gives you a much bigger chance of getting a solution right, as opposed to just thinking, well, this building could be big enough for 40 cattle, but actually I can only put 20 in. That's not efficient. So if we had 40 cattle in here, or we wanted it to work for 40 cattle, to double its current productivity, we need 40 times 0.1 square meters a hole in the roof. That's 4 square meters. We look up at the roof and we find that we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of these crown roof sheets, and one of those is enough for 2/3 of 1 cow. So we've actually got enough outlet in the roof for 7 cows, and we need enough for 40. So really what this building needs is 4 square meters of hole in the roof, and you give it that provides the outlet for the heat and the moisture within the building. No point doing that though unless you're also prepared to sort the sidewalls. And so here we have vented sheet, much loved in Scotland, Cornwall, Devon and the whole of Ireland. Unfortunately, it's sold by the buildings people as being a ventilated wall, but it is actually next to virtually useless. What's the solution? Well, a thing like this, again, it doesn't cost a lot of money. This thing here, the purlins, this sheet needs to be pushed out from the wall. If you pushed it out 8 inches all the way along the bottom, that's 0.2 of a meter. The building's just over 20 meters long. 20 meters times 0.2 is 4 square meters. We would have a 4 square meter gap in total all the way along the bottom side of this building. When the wind's blowing, which it does a lot, it's going to hit the wall on the outside, change direction, drop water, drop snow, drop energy, come up inside the wall, between the wall and the wall sheet, come up, hit the purlin and come into the building. Important detail here, there's no point pushing this out by 200 mils, 8 inches. There's no point pushing it out by sticking another piece of wood on top of this, because it's the smallest gap that matters. And actually what we need to do here, there's a steel plate. I need another steel plate somewhere up here, another one the other end. Undo the fixings on the outside, take this purlin off, put it in higher up, and now I've got a gap where I've got not only 200 mil and the vertical plane, I've also 200 millimeters in the horizontal plane as well. That's how you would turn a building like this, same building, we're talking a few £100, if it's all done safely, must be done safely, a few £100 would turn this from a 20 cattle building to a 40 cattle building. Okay, here we have different again, beef shed, all on slats. And what's quite interesting about the difference between slatted systems and straw systems is actually the energy dynamics are slightly different, because you have a higher stocking density in buildings like this, so we have a lot more energy inside the buildings coming from the cattle. So pretty good here. It's quite a high volume building. That can be good and bad. We'll just leave it at that at the moment. But again, we just worked through what we need in terms of ventilation is a ballpark 0.1 square meter of hole in the roof. So in here we have 120 cows and 120 calves. So for the 120 cattle themselves, we're going to need at least, or a ballpark figure of 12 square meters of outlet in the ridge. You add the calves to that at a lesser number, which might be another 4 or 5 square meters. We're looking at a ballpark figure of 15, 16, 17 square meters of aperture in the ridge, which will be more refined if you do the next iteration of mass. You look up and see what you actually have. And originally in this building, there was a series of crank ridge sheets, which the mass turned into approximately 1.3 square meters. So this building, although it's relatively new, was built with about 1/10 of the outlet in the roof that's needed. There's been a number of changes made. So the inlets, which we're looking for a minimum of the same as the outlet area in each side wall. So if we needed 15 square meters in the ridge, we need 15 square meters in the side wall as inlet, which is absolutely no problem, because the building is 1, 2, 3, 4, 5, 6, 36 meters long, a meter high gap through the feed fence. We've got 36 square meters of inlet on either side, job done. The issue in here, the building is tight because of the ridge. Now, it has been helped by, if you like, getting a higher level outlet at the top of the wall. It can be an inlet, can be an outlet, but if it's too stuffed up there, it's generally helping. There's a really good overhang on the roof, which again is a very good way of protecting the wall. So as a basic design feature, we need more roof as an overhang, which allows us to have less wall because it protects the wall. So really, there's a bit of improvement has been helped by changing the side wall, but the biggest impact is being made up on the ridge, where a number of the whole complete ridge panels have been taken off, providing, what did we work it out at, but an additional 3 square meters of outlet in the roof. You're doing that with no capital cost. It needs to be done safely, which is going to cost a bit of time and money, but we've basically, whilst we're still short of outlet in the roof of this building, you can see he could do the same again, and he's going to take the outlet from 10% to 40% to 70%, improving all the time. Otherwise, pretty good building, high density. This is part of the future, especially if straw gets more expensive. What we're looking is for the air to disperse from a building within sort of 45 to 60 seconds, and we'll let it go and see what happens. So generally hot air rises. The energy is coming from the cattle. We have a lot of cattle in the building. Hot air rises. The smoke is just a way of describing where the air patterns are. And you can see it's looking to find its way out the building.